Hello friends, welcome to New Generation. This is Arano, and from today we will start a new journey for GATE 2019 Civil Engineering. And the first subject what I am going to start is highway engineering. So at first let's see the sub chapters of highway engineering. Okay, the contents. The first chapter is geometric design and planning. Second one is highway materials. Third is traffic engineering. Fourth one is pavement design. And last but not the least is highway maintenance. From this first chapter, traffic engineering and geometric design and planning, these two chapters carries more weightage than others. Highway material is also an important chapter. Pavement is also an important, but highway maintenance is not that much important compared to other four chapters. Okay, so let's start highway engineering. Okay friends, so let's start. The first chapter of highway or transportation engineering is geometric design. So let us see the first definition of geometric design. The definition is geometric design is an aspect of highway design dealing with the visible dimensions of a roadway. It dictated within economic limitations by the requirement of traffic and includes the design element of horizontal and vertical alignment, etc. So now by definition, we can see that it means the design of road with considering all environmental and topographical and economical conditions by fulfilling the requirement for the safety of travelers. Okay, so let us consider some highway design elements. So first one is design speed, second one is friction, third one is pavement unevenness, fourth one is light reflecting characteristics, and last but not the least is camber. Okay, so let's start. The first property of geometric design is design speed. Design speed is that much speed which is less than the actual speed. Suppose a car can move through a highway with a speed of 100 km per hour, but the design speed should be less than the actual speed. That can be 90 km per hour or 80 km per hour as per design. Okay, and the design speed of a highway is depends on two factors. The first factor is importance of road, and the second factor is terrain or topography. Now, what is topography? Topography means all environmental condition of the particular site where road will be constructed. Okay, and IRC, the Indian Road Congress, has provided some guideline about the design speed during the design of a particular highway. Now, they are separating the roads in various ways. NH stands for National Highway, SA stands for State Highway, MDR stands for Major District Road, ODR stands for Ordinary District Road, VR stands for Village Road. Now, plain, rolling, hilly, steep, these all are terrain, different terrain. These terrain are different in the way of slope, because rolling terrain is more steeper than plain. That means slope of rolling terrain is greater than plain terrain, and slope of hilly terrain is greater than rolling terrain. So now you can see that for national highway in plain terrain, the design speed is in the range of 100 to 80 km per hour. For rolling terrain, it is 80 to 65 km per hour. And this is the chart which is provided by the IRC, and this is also an important chart. In GATE, they might be asked questions from this chart also, such like that, the for ordinary district road, what is the value of design speed in hilly terrain? Okay, so let's start the next property, friction. Friction is when a vehicle negotiates a horizontal curve. The lateral friction developed counteracts the centrifugal force and thus governs the step operating speed. The first property is longitudinal friction. Now, what is longitudinal friction? Longitudinal friction is the factor which helps to resist the centrifugal force. Suppose, let me draw. Uh, Suppose this is a road and there is a car. And I'm sorry for this type of drawing. Okay, suppose this car is moving by this curve. This is a horizontal curve. Suppose there is a slope of theta. Okay, now this car is moving towards this slope, and when the car is passing through this slope, it will feel a outward force called centrifugal force. This force can overturn the car in this direction. Okay, so to resist this centrifugal force, longitudinal friction will generate in opposite direction to centrifugal force and helps to create equilibrium. Then there comes lateral friction. This also helps in this type of equilibrium condition. Then comes slip and skid. Under friction, this longitudinal friction and lateral friction both are helping to resist the car to overturning or any kind of accident. By IRC, they provided some limiting value of longitudinal friction and lateral friction. For longitudinal friction, the value is 0.35 to 0.4, and for lateral friction the limiting value is 0.15. So please note down this point. For longitudinal friction, the limiting value is 0.35 to 0.40, and for lateral friction the limiting value is 0.15. Now there comes a term is called slip. Slip is when a vehicle rapidly accelerates from the stationary position or slow speed. In that case, vehicle's wheels revolve faster and known as slip. Okay, in easy term, we can say that when a vehicle stuck in any position. Okay, suppose this is the vehicle stuck in any position or it can't move, then the number of revolving or the amount of revolving of this tire, okay, the amount of revolving this tire is more than displacement of this car. Okay, then this phenomena is termed as slip. And what is skid? When the revolving is less but displacement is more. Okay, now you can easily understand the difference between slip and skid. Slip is when revolving is more, revolving of tire is more and displacement of car is less, then it is termed as slip. And when revolving of tire is less and displacement is more, is termed as skid. Okay, So move to next property. Then there comes pavement unevenness index. Now, what is pavement unevenness? The pavement unevenness it indicates the cumulative vertical undulation of the pavement surface per unit horizontal length of the road, and it is expressed in terms of centimeter per kilometer. For good pavement, the value of pavement unevenness is 150 centimeter per kilometer. For speed of 100 km per hour, pavement unevenness should not exceed 250 centimeter per kilometer. For speed of less than 55 km per hour vehicle, the pavement unevenness should be 350 centimeter per kilometer, and the pavement unevenness measured by the instrument called raphometer or bump indicator. So move to next property, camber. Okay, camber is an important element for geometric design. Camber is the slope. As you can see, that camber is the slope is given to road pavement in cross section. It is used to drain out the rainwater into side drains. Camber helps to remove all the drain water after the rainfall, for make the road dry and smooth. And the other property of camber is to make the surface dry soon, so that skid resistance does not reduce, and it helps to reduce the probability of accident. And the last point is prevent entry of surface water into subgrade soil, so that the subgrade should be more harder. Now, the camber depends on amount of rainfall and pavement surface. Camber depends on means the design of camber. That means how much camber we should provide. That depends on amount of rainfall in that particular phase and pavement surface. Now, there are three types of camber. The first one is parabolic camber, second one is straight line camber, and the last one is combination of straight line and parabolic camber. Now, we will see the advantage and disadvantage of these three cambers. The first one is parabolic or elliptical shape camber. Now you can see that it is an parabolic camber, and at the topmost point it is termed as crown, and the dotted one, that means this line, it is termed as 1 in. This is the slope. This is basically defined the slope of this camber, 1 in, and y is an arbitrary vertical distance, and x is also an arbitrary horizontal distance. By this distance, we can generate the empirical formula for parabolic camber is y is equal to 2x square by nw, where w is the total width of the road. Okay, and this is the empirical formula for parabolic or elliptical shape camber. Okay, now let's see the advantages for parabolic camber. The advantages are the profile will be flat in the middle and steeper at the edges, and other advantages are it is preferred by fast moving vehicle, otherwise it will stuck it at the crown position because it is so much steep. And disadvantages of this camber is at the edge are steeper, the slower vehicle can overturn while driving, and hence they try to occupy the crown position, resulting the traffic. Okay, now move on to next camber is straight line camber. Now straight line camber, for the advantages of straight line camber is here is uniform cross sectional slope, and it is generally provided in cement concrete pavement, and it is preferred for slow moving vehicle also. And disadvantage is it is not preferred for fast moving vehicle because it causes jerk crossing the center line. Okay, and we can say that the distance from ground to the crown distance from ground to crown is defined as W by 2n. Here 1 by n is also defined the slope. Okay, here 1 by n is also defined as slope. In previous case also 1 by n is termed as slope, and here also W is the width of the road. Move on to next part. Now the last case is combination of straight line and parabolic camber. This is more suitable camber and comfortable to slow and fast moving vehicle also. Okay, so move on to next part. Okay, in this picture I am showing that in real life how the camber is looks like. The topmost point is termed as crown, and the initial and ending point of this zone or camber zone is called as curve. I will later describe you what is curve actually. Okay, move on to next point. IRC values for camber. IRC, the Indian Road Congress, provided various values for various conditions, just like for heavy rainfall, for light rainfall. For heavy rainfall, they provided different value for different road type. For cement, concrete, and high-type bituminous surface in heavy rainfall, the camber should be 2% or 1 in N value is 1 in 50, and for light rainfall it is 1 in 60 or 1.7%. There is also thin bituminous surface, there is also waterborne macadam and gravel pavement and earth surface. You have to by heart these values because in EAC or GATE or SSC they can frequently ask the values of camber for different types of road in different condition like heavy rainfall or light rainfall. So next is okay, now the maximum width of vehicle which is provided by IRC cannot exceed is 2.44 meter, and width of carriageway. IRC provided different width for different types of road. For single lane, the width maximum is 3.75 meter. Two lane with raised curve is 7.5 meter. Intermediate carriageway is 5.5 meter. Multi-lane road is 3.5 meter each. That means if there are 3-lane road, multi-lane means more than one lane road. Suppose there are 3-lane road, then the width should be 3 into 3.5 because each lane's width is 3.5 meter. The minimum shoulder width should be 2.5 meter. Okay, this is the end of this video, and in next video we will solve few basic questions of camber, and I am requesting you guys please note down all data and information which I had provided in charts in this video because that are very useful. Thank you friends for watching this video. I hope this is a useful video, and in this video I had provided lots of data and information because now the trends of GATE questions are changing and informative questions are increasing rapidly, not only for GATE, this is for EAC and SSC also. So hope you like this video, and if you like this video, so please hit the subscribe button. Thank you.